Three identical point charges Q1, Q2, and Q3 all have positive charge, plus Q, and lie on the xy plane. Their relative locations are indicated directly on the diagram. Question 1, Part A says determine the electric force of Q1 on Q3 and make sure the answer is listed as a vector. So first, when you do this problem, force of Q1 is equal to Q1 times electric field of Q3. So first you set it up with the equation, making sure that you are also multiplying it by the direction of vector r, and then you solve for r. When you solve for r, you have to do r observation minus r source, and when you do that, you end up getting 4d negative 6d 0. When you do this, you can also find the magnitude of r, and when you do that, you get d square root of 52. Then you can find the direction with both of these components. Our direction would be 4 over the square root of 52, negative 6 over the square root of 52, and 0. Finally, you can substitute all the components of the equation EQ3 and solve for force of Q1. The second part of this question asks to determine the net electric force on Q2 and to also answer this as a vector. So when trying to find the net electric force of Q2, you need to add up all the forces that are on Q2. When doing this, you have to take into account the force of Q1 and add it to the force from Q3. By taking out the positive Q, which is stated in the question in the beginning, you can just add the electric fields of Q1 and Q3. We have already found the electric field of Q3 from Part A. So for Part B, it's crucial that we find the electric field of Q1. When finding Q1's electric field, use the same equation for point charge. When finding R, again, you do R observed minus R source. When doing this, you get 4d, negative 3d, and 0. You again find the magnitude of R by doing the square root of 4d squared plus negative 3d squared plus 0 squared, and you end up getting 5d. With both of these components, again, you can find r hat, which is the direction. Our r hat ends up being 4/5, negative 3/5, 0. With all these components, you can find electric field of Q1. With electric field of Q1 and electric field of Q2, again, you can add both of these and multiply by positive Q, and you end up getting your total force Q2 and the direction.